So let me talk about ISO OSI stack. Okay. What it is first of all we need to know what is computer network. I'm going to give you a basic of it. That computer network is something that we have developed or connected in order for computers to communicate with each other, and specifically talking about processes to communicate with each other. Like when you send a message on WhatsApp, the other person is going to receive it on WhatsApp, not on Telegram or not on Instagram or anything else. Why? Because process gets connected to process. That's the end of it, right? Uh, that's the most necessary part of it. Then we talk about what all other things that we need to do uh, in order to have a healthy connection. Okay, in order for it to not get problems every now and then, and to establish it securely, and all that things. So we came up with, and there are a lot of things that has to be done. Like flow control has to be done, because your data flows from one computer to another, and that flow has to be controlled. So flow control is there. Error control, because there can be a huge distance that the data has to cover, and in between there could be noise in the signal. Noise as in any kind of noise. Just consider this: if the data is being sent through a wire and somebody steps on that wire, that as well is a noise. So if there's noise, then there can be error, and that error has to be controlled. There has to be an access control method. What is access control again? If I have sent a data to somebody, only that person needs to receive that data, not so that data has to be received by that person only, and not everybody else. And the access, that means the access of that data has to be given to only specific people who I have authorized. So, or the sender has authorized basically. So that has to be done, and there are a lot of things that has to be done, and there are a lot of optional things that can be done. So we came up with and we classified things into different layers, and we came up with a reference model, and one of those reference model is ISO OSI stack. Okay, what it stands for, that's not important. That's something internet something internet service organization, something like that. You can Google that, and that's not at all important. But it's a reference model where we do things in order to get all the things done in a good chronological manner. Fine. So first of all, the benefit. Let me talk about all the benefits here. The first one being that we can divide and conquer. What can you divide and what can you conquer? All the things that you have to do, you can divide those things into different layers, and with different layer there comes a like okay, so you can divide it in different layers, and each layer will have its own functionality. Okay, so you can divide and conquer your work. And the second benefit is encapsulation. You can do all the things that is like similar kind of tasks, you can do it in one layer. That's how you encapsulate. So you divide and conquer among layers, you encapsulate in layers, and then there's abstraction. That needs not one layer need not know what the other layer has done and is doing. That can be hidden. Abstraction means hiding the details. So every layer, so any layer does not need to know everything about what the other layer has done. It just needs to know what is just necessary for it, for its own function. But other than that, you can hide all the details. So abstraction between layers. Then there's testing is easy. You can test layer by layer, and that's how testing becomes easy. Okay, so then we talk about Now, what are the other examples of this reference model that I said that ISO OSI is one of the reference models? What are others? There's another there, which is TCP/IP, and there's ATM, there's X.25, there's IEEE. Okay, and for us, it's just ISO OSI and TCP/IP. That's the important. Those are the important ones. Okay. Now let's talk about what are the layers in ISO OSI stack. We have 7 layers. Okay, I guess 7. And the way to remember it is, please do not touch Steve's pet alligator. Fine. So there's physical layer at the bottom of it, then there's data link layer, then there's a network layer, then there's a transport layer, then there's session layer, and then there's a presentation layer, then there's application layer. So application layer is the layer that we deal with, that the user deals with. We deal with 3 layers. So application layer, presentation layer, and session layer are the layers that we deal with, and these all are combined as one just application layer in TCP/IP model. Okay, but here let us talk specifically about what each layer does. So the first layer that we interact with, that's just consider yourself as a sender. You interact with the application layer in order to send or create the message. Okay, so you create the message here, whatever you need to send. That message, basically, it's not even a message. Like, don't think of it as a text. You might be sending a video, you might be doing a live broadcast, you might be doing whatever you are doing. You're basically sending data. Whenever you're on the internet, if you are uploading anything, you're sending a message. Whatever you're doing, that's just sending data. So when you're sending data, think about this. You're just interacting with the application layer first of all. Okay, you're just interacting with the application layer. Now you may do something more than that, but you may not realize it. First of all, while you're creating the data, that's on the application layer. So considering if you're typing a message, that's when you're creating the data, and that's on the application layer, which just has user interface. Fine, with which you deal with. Then there comes presentation layer, on which what do you do? On presentation layer, what you do is you first of all, what is going to happen is, now see, we write things in English, Hindi, or whatever language that we speak or we communicate in. Okay, but that is not the natural language for computers, right? So that thing has to be converted into bits. So what happens at presentation layer is the high level language that we write things in gets converted to bits first of all. So the high level language that we deal with gets converted to bits. Okay, then what happens is, if we need to encrypt the data, while sending it we're going to encrypt it, while receiving it we may decrypt it. If it was encrypted, then we have to decrypt it in order to read the message, of course, if you're authorized. Let's not talk about that. First of all, let's talk about presentation layer. So first thing is that high level language gets converted into bits. Okay, then that bit has to be encrypted in order for it to be protected from other because it's going to go through a lot of routers, and those routers are connected with a lot of computers, and those computers, if they should not be receiving that data, they should not be, even if they are trying for it, even if they are trying to read that data, they should not be able to read that. So for that purpose we encrypt that data. Okay, so we encrypt the data. We may need to encrypt the data, then we may need to compress that data. Okay, you might be sending a lot of data, and that data can be compressed so that the communication can be faster, so that you do not have to send a lot of data packets. So we may need to compress it, like what YouTube does to you. You may realize it or not, but whenever you go for 4K, it's not exactly 4K. It compresses that data, like Instagram does. All the reels are blurred, because even if you upload it in the highest quality possible, it gets compressed, and that's the compressed version of it, which you can actually feel on Instagram, but you may not realize it on YouTube. So that's the kind of thing I'm telling you. And then we come on to session layer. What session layer does is, the basic thing is that, just keep in mind this one part, that session layer is responsible for authorization and authorization and authentication. What is that? First of all, authorization, that is done on the sender's part. Okay, so if you're using your Instagram, you have logged in as a person, as a user, you've logged in, and if you're sending somebody some message, then you are authorizing only that person. You are not realizing this, that what you're doing is also you're also authorizing and authenticate, you're also authorizing right now, but you're doing it, you're sending to one particular person. That's how you're authorizing that person only to read your data, and that person will be authenticated by Instagram security, that he has to log in with that particular account on which you have sent the message, and he will authenticate himself or herself, and then he reads your data, whatever the data you have sent. So that's where it comes, that authorization and authentication. Okay, then let's move on to what other things that it does. There's things like, while you are streaming some movie or some whatever content, right? So there has to be a dialogue control that is done. Okay, that's going to be on the receiver side. First we are talking about the sender side. There has to be synchronization, so you try to maintain that synchronized. In what sense? The data which is being sent, it should always feel like, you're streaming in order, right? You do not want to watch a movie in different parts from, certain different parts from certain different areas. Like, you do not just want to, you want to watch the movie in order, right? Not from random seat times. So that's what gets taken care of with synchronization. Now come on to, now these three are the layers that users deal with, and you may realize it, you may not realize it, but you're dealing with it. Then there comes the next layer, which is transport layer. Now transport layer is responsible for, wait a minute, please do not touch Steve. Yeah, transport layer. So transport layer is responsible for the end-to-end connectivity, that is process to process communication. Okay, so up until now we have just created a data packet, that's all we have done. Okay, up until now we have just created and organized our data and made it ready to be sent, and now's the time that we prepare ourselves to not prepare ourselves, but now is the time that, yeah, we basically prepare the data to be sent. Okay, so what do we do first is we come on to transport layer. And on transport layer, this is responsible for the end-to-end communication, which with which I mean that process to process. Basically, if you're talking on WhatsApp or Instagram, then Instagram to Instagram or WhatsApp to WhatsApp, that's the process to process. That's going to be the communication. Now what do you do while doing that? When you come onto the transport layer, every process has its own port number, and the famous port numbers you can actually look for it. Like HTTP has some port number, and a lot of other things have their port numbers, which you can just search on the internet and you can find. So port numbers are added on the transport layer. Then port number, with port number you actually understand that which process has to be the one, I mean, which process do you need to send. So if you're sending some data, and you're sending it on WhatsApp, so with transport layer it's assured that that person is going to receive it on WhatsApp and nowhere else. Okay, so that, for that we have to add the port number. Port number specifies that this is the process that you need to send the data on. Fine. Then we come on to the next layer, which is network layer. Now network layer, it's an optional field, and why is that, I will tell you later. But first of all, let's talk about what is network layer. First of all, it's important in its own sense, but it's optional as well. It's important if you want to connect to host or computer which is not in your network. So you need inter-network communication. To establish that, you have to have network layer. If you do not have network layer, you can obviously communicate between under your network, whatever local network you have, you can communicate between them, but you cannot communicate to some other host which is in some other network. So for that you need network layer. What do you do on that network layer is, the message that you were having right now was the message, everything, the encryption, decryption, or whatever you did, whatever you added, whatever you converted, translated things in, and then you added port numbers to it. That was the message, that was the whole data that you were having right now. Now what do we add on to it is IP address. You are assigned an IP address while you're on internet. Whenever you turn on your internet connection, whenever you turn your data on your phone, that's when your internet service provider provides you with an IP address. An IP address is a logical address. An IP address is a logical address which is unique to you at that moment. At that moment, if you're having an IP address, at that point, that IP address cannot be assigned and is not assigned to any other person. Okay, so it's unique. It's a 32-bit field and it's unique. So what do you add here is IP addresses. What IP addresses? The first IP address is going to be the source IP address, and the second one is going to be the destination IP address. Of course, the destination IP address tells you where that data has to be sent. Okay, that has to be the destination IP address. Now think about this. Why is it important again? Because destination IP address, now think about this. Now, like, you can have WhatsApp open on multiple devices, but you receive and you receive it in all of those devices, right? So it's something to think about. Let's just not go there. So first of all, let's just talk about we add destination and source IP address. Okay, source IP address is where if I receive some data packet, then I need to know who sent me that. So for that matter, source IP address is added. Destination, where I have to send it. Okay, now this IP address, why is it assigned when I turn on the internet, and why is it not just fixed for all time? Why do I have to go through this? Why? So why is that? Is because you do not want just any random person to know your phone number, to know your address, physical address. Nobody wants to share that, right? I would not share my address with somebody that randomly just talked to me over internet, and just whatever, for whatever reason he's asking for the address. I'm not comfortable sharing that, but I am comfortable sharing my and I'll be comfortable sharing my Instagram account rather. Well, personally, I am not even comfortable with that, but still, you'll be more comfortable sharing that instead of your phone number or your physical address. So that's the point. IP address is something which is not that private to you, while your MAC address, your physical address, is something very private. MAC address is not something that you share with anybody. Basically anybody. You do not, it's like your ATM pin. You do not want to share it with anybody. Your MAC address is the address of your device. IP address is the address of your basically when your device is registered onto the internet for use. That's when you're assigned the IP address. So it's just it's just holding that information that this MAC address is having this IP address, and with IP address you're going to be known, and only your internet service provider knows which that which MAC address is having what IP address. Nobody else needs to know. They can know, there are hackers and all, but that's not legal, and it's not. And MAC address is something which is fixed. So understood. This part was that IP address is something which can be shared, while MAC address is something which is private and you do not share it with everybody. That's why you share for global identification we use IP address. Okay, so at network layer we add IP addresses, source and destination. Okay, then we move on to the next layer, which is the data link layer, right? Please do not. Yes. So then we move on to the next layer, which is data link layer. Now, on data link layer, what happens is, on data link layer, what happens is you add the MAC addresses. Now, MAC address is something physical, and I was just telling you that it's private. It's something that you do not want to share. So that is going to be accomplished here. You add your MAC address here. You do not, your computer does, because the router should know that the correct IP address, the correct person is actually sending this thing. So the router needs to know that. So you tell the router that this is the MAC address, this is your MAC address, and then you specify the router's MAC address. You add the router's MAC address, not the destination MAC address, not the that person's MAC address to whom you're sending the message, but you add the router's MAC address, because you do not even know the MAC address of the person that you're sending the data to, right? And you cannot know. It's not even legal to know. Okay, so you add the MAC address of the router, the next router that you're sending that data to, and you also specify a certain more things. One is starting frame delimiter, and another one is end delimiter. What is that? Is starting frame delimiter is something that we call as like बारात आती है तो उसके आगे बैंड बाजा वाले चलते हैं, एंड वो वही बोलते हैं कि बकरा आ रहा है, बकरा आ रहा है. सो स्टार्टिंग फ्रेम डेलिमीटर टेल्स दैट द डेटा इज कमिंग, get ready to receive it, data is coming. End delimiter is something that specifies that the data is over, or at least that this data packet is over. So that has to be told, because a lot of data packets are going to be received. If they are received in a sequence, and if the computer, if over there it does not gets to know if one data packet has ended or not, it may just get all of the data wrong. And to avoid that, we add end delimiter, with looking at which it is clear that one data packet is over, and I might have to receive next one. If there's another one coming, then I have to receive it. Okay, so that is what happens at data link layer. Now comes the physical layer. Now, what is physical layer? What happens over here is now physical layer is what we call as the wire as well. Okay, basically the wire, or whatever medium you're connected with. Like if you talk about your phone is not connected with any wire, but the communication is happening. So how is that happening? Those are other signals. Okay, those are some medium of signals, and these medium of signals can only work if there's a cell tower near you. Okay, and in your range, basically, not near you, like what you may consider near, but what your device considers near. It has to be near that, and that's the range. Then that satellite communicates that cell tower communicates with the satellite, or it does something else. I don't that is way too much detail, and it's actually not to be explored by. It's not something that I would like to explore right now. I might do it someday else. But let's talk about physical layer. And while we are saying that, we are dealing with wires. Okay, so basically wires. Now everything has to be sent through a wire. How do you send everything through a wire? First of all, bits are not understood in wires. That thing is sure. Bits are not understood in wires. What is understood in wires is just electronic signals, okay, or any other signal is basically understood. So we have to convert our data in that form, okay, and what do we call it as? We call it baud signals. There are other methods. There are two encoding techniques, at least two which I know: Manchester and differential Manchester. And you can look up how 0 and 1 is represented in baud. But that, again, the representation of 0 and 1 in baud is something that we see. I mean, we have represented for our ease. It's not something that is being sent, of course, right? Because you are sending electronic signals. It's not if I'm making some random symbols, those symbols are just understood by me. The electronic signal can be different, right? It may look different. It definitely looks different, right? It's going to have certain properties, or whatever you call it. So basically, yeah, so it sends signals. That's your physical layer. Now talk about at the router. The first thing that you communicate with is the router, and there can be a lot of routers. That means in sequence you may have to go through a lot of routers. The first router, what it does is it receives that data on physical layer. Then it has its own data link layer. It has two data link layers. It is connected to two data link layers. One would be the incoming side and one would be the outgoing side, while it has one network layer. Now why is that? Because at physical layer it receives the data, the other physical layer it will send the data. At one side data link layer it will be seeing the MAC address, and at the other side of the data link layer it will be editing the MAC addresses. So like it saw that, okay, this is the MAC address of the sender, okay, and then it sees the receiver MAC address, that is his. So so the router knows that the data was meant to be sent to me, okay. Then what the router does is, according to it has a network layer on which it sees the IP addresses. According to the destination IP address, it it edits the destination MAC address. So it will add the address of the next router or the next hop, or if it's the person, let's just say that there was just one router, so the router will add the destination MAC address of the person that you, or of the computer that you wanted to send the data to, and as source MAC address it will add its own MAC address, okay. Again, at the receiving end as well, it is ensured that the sender does not lose its his or her privacy of MAC address. That MAC address is not known uh, to the person, to any person, to anyone. So router may gets to know it, but router is not any computer or any host. It just has three layers only: physical layer, data link layer, and network layer. So other than that, it does not have application layer, so nobody is actually going to be understanding what router is doing or what router is dealing with right now. So that's how the router does things. It edits the MAC addresses and then sends it to the next hop. And let's just say, for the ease of it, that all the routers that had to be in the middle, they all went through all this, and now you're at the receiver side. So what will happen on the receiver side? First of all, physical layer. At physical layer you receive the baud, fine. Then you convert that baud into bits, fine. And then there's start frame delimiter, which is going to tell you the data is coming, okay. Before that, if you were dealing with another data packet, then you'll be seeing its end delimiter as well, and you know that one data packet is over. Now you see another start frame delimiter, that is, okay, another packet is coming. You get ready for it, and then you go through all of it. What do you go through? First of all, you received it in data link layer. Now the MAC addresses are deleted. Why is it deleted? Because that was not the message. You did not want to know the MAC address, IP address, or anything. You just had to know, if somebody sent you a hi, you were just meant to see hi, okay. You were just supposed to see hi, not anything else, right? Not the MAC addresses, not the IP addresses. You did not have to see all of that. So the MAC addresses are removed here, okay. Your computer does it. SFD and end delimiter, start frame delimiter and end delimiters, are also deleted at the physical layer and sent to the data link layer. Sorry. At data link layer, SFD and ED are deleted, MAC addresses are deleted. Then at the network layer, it will first check the IP addresses, who sent it, and if the receiver that I am, let's consider I am the receiver now. So if I was supposed to receive this data or not, so it will check that. The IP addresses will be checked. then IP addresses will be removed. Then talk about port addresses. That's when we are on the transport layer. When we are on the transport layer, it checks the port numbers. So which process is this message supposed to be sent to? So according to the port numbers, it will be passed on to that process only. Then those port numbers are deleted, okay, at the transport layer. Now comes on now there's another thing, that is session layer, authentication. Okay, there's going to be authentication. There's going to be authentication if you had to be authenticated, like Instagram authentication. If you were meant to be seeing this data, then only you're going to be seeing it. Then there's going to be this synchronization was done at that part. The data was sent in a synchronized manner, so you receive it in that manner as well. So let's talk about if you were watching a movie. Okay, so dialogue control has to be done, that the dialogue are actually synchronized with the video. Okay, then there's something which is synchronization. That part gets done. Yeah, basically that. Then there comes on then there's presentation layer, where what happens is, if the data was encrypted, you need to decrypt it. If the data was compressed, you need to decompress. Okay, that happens. Then also, what the data as it was right now, it was just zeros and ones right now. Now you were meant to be seeing high. You were supposed to see high. You were not supposed to see some random sequence of zeros and one. So that zeros and one, from the machine level language, it gets converted to the high level language that we speak. So after all this, you come on to, so yeah, one thing that I was saying, that network layer is actually not necessary. Why is that? Because you're it's not for certain that you're going to be communicating with a device which is not in your network. Fine, if you just want to communicate with somebody who is in your own who is in your local network, so you do not need the network layer. You do not need the whole, so you do not even need the IP address. You can just communicate with the you do not even need the router. You can just connect to a switch, and that switch will direct onto the correct interface, basically to the device that you wanted to connect to. So it will just send your data over there. So network layer will not be necessary in all the cases. But if you want to communicate with somebody who's in another network, or if you want to communicate with all the computers, if you want to broadcast something, that's when network layer will be necessary. It's important for that. You come on to the application layer, that is the user interface, where you see a message that pops up, hi. Okay, now we shall move on to the other things. Those would be pretty much, this is all, but I mean, I can go into details about a couple of things that can be done, but that won't be the basic of it. That would be a little bit detail of it. So let me get back to you in a while.